This is Gangadhar. In this video, I am going to deal with transversal line in geometry. What is meant by a transversal line? And angles, type of angles, and the number of angles which are involved with the transversal line. And at the end, we are going to discuss the relation between transversal with the parallel lines. See, first of all, transversal line. Transversal line is a line which intersects two or more lines at different points. It has to intersect many number of lines at different points is called a transversal. For suppose I have here four lines like L, M and P, and these four lines are intersected by this transversal at four different points. Since this line T is intersecting four lines at four different points, this T is called transversal. So transversal is basically it has to intersect two or more lines at different points, right? For suppose if I take some more number of lines, see if I take some more number of lines, if this transversal intersect all these lines at different points, so then this tree acts like transversal for all these lines. And for a set of lines, there exist many number of transversals also. For all these lines, this line T is the transversal because it is intersecting all these lines at different points. For suppose, if you draw one more line like this, such that it has to intersect all the given lines at different points, then we also call this also as another transversal. Like this, for a set of given lines, we may draw many number of transversals. For suppose, this is another transversal and this is another transversal. For a set of lines, there exist many number of transversals, and basically transversal line is a line which intersects two or more lines at different points. That is the concept of transversal. For suppose I have some lines like this, line, line and then line. Okay, if I draw a line which is intersecting these three lines at different points. For suppose if I draw a line like this is intersecting these three lines at three different points. So I call this T as the transversal for all these three lines. For suppose if I draw a line like this. If I draw a line like this line is intersecting first line at this point and the next two lines at this point. So this line is not mentioned as transversal for all the three. For suppose if you name the lines as L1 and L2 and this line as L3, see, and this transversal is suppose mentioned as some T1. This T1 is not a transversal for L1, L2, L3. This T1 is a transversal for L1 and L2. If you take L1 and L2, this T1 is intersecting L1 at this point, L2 at this point. So we call it as transversal for L1 and L2. And we also call T1 as transversal for L1 and L3 also. But we don't call this T1 as transversal for L2, L3. Because this T1 is intersecting both the lines at same point. So it is not a transversal. That's why in this case, this T1 is transversal for L1, L2. This T1 is transversal for L1, L3, but this is not a transversal for L2, L3. And whereas in this case, this line T is intersecting all these three lines at different points, so we call this T as transversal for the set of three lines, right? And coming to this, here I have a diagram. I mentioned three lines as Q, R, S, and if you look, the lines Q and R are intersected by S at two different points. So S is a transversal for both Q and R. And in the same way, the line Q, this is the line Q, which is intersecting the line S at this point and the line R at this point. So this Q is also called transversal for R and S. And in the same manner, the line R is intersecting S at this point and Q at this point. This R also acts like transversal for S and Q. So in this diagram, Q is a transversal for RS, R is a transversal for SQ, S is a transversal for QR. Okay, whereas in this case, T is a transversal for the given set of three lines and T1 is not a transversal for the set of three lines. This T1 just acts like transversal for either for L1, L2 or for L1, L3. So finally what I am going to conclude is transversal is a line which is intersecting two or more lines at different points, right? So I discussed in examples also. Now the next task what I am going to deal is, for suppose if I have a transversal with two lines, the lines may be parallel or the lines may be perpendicular, intersecting. For suppose these are the two lines which are intersecting. Name the lines as L and this line as M. In the same manner, if you take two lines, line as L and another line as M, right? See, if you observe, these two are the parallel lines, whereas these two are the intersecting lines. Now I am going to draw a transversal for this set as well as for that set also. So this is the transversal. Why we are calling it as transversal? Since it is intersecting these two lines at two different points. Whereas for this case also, if you draw a transversal, it intersects these two lines at two different points. And now if you observe this transversal while intersecting two different lines, it makes 8 angles here. 1, 2, 3, 4. And coming to here, 5, 6, 7, 8. Similarly here also. This is angle 1, angle 2, angle 3, angle 4, 5, 6, 7, 8. Actually we need to mention it as like 8 is a number and it is indicated by angle 8. So there are 8 angles. The measurement is not that 8, right? So there are 8 angles. Everywhere we need to write like this, angle 8. But for our convenience we are just mentioning the numbers, right? So here we have 8 angles with a transversal. There we have 8 angles with a transversal. And if you look, we will name all these 8 angles in different forms, right? See, if you look, here we have 1, 2, 3, 4 and this is 5, 6, 7, 8. So this set of 4 angles correspondingly there here like 5, 6, 7, 8. So what I am going to say is, for this 1, this 5 is corresponding. In this case also, for this 1, this 5 is corresponding. Now, I will mention certain names which are correct for both the cases. See, look, angle 1 is corresponding to angle 5, angle 2 is corresponding to angle 6, 3 is corresponding to 7 and 4 is corresponding to 8 if you look. So clearly this set of 4 angles are corresponding to this set of 4 angles. So 1 and 5 is called a pair of corresponding angles, 2 and 6 are called pair of corresponding angles, 3, 7 a pair of corresponding angles, 4, 8 also a pair of corresponding angles, right? So corresponding angles means one angle here and another angle corresponding to that one in this lower set. This is corresponding angles. And interior angles. See, we have two lines there and here. So angles which are in the interior region of these two angles are called interior angles. So here 3, 4, 5, 6 are the interior angles. 3, 4, 5, 6 are the interior angles. So automatically 1, 2, 7, 8 outside angles will become exterior angles. And then either interior or exterior. See, if you look here, totally how many angles are formed? Totally there are 8 angles. These 8 angles are classified into two categories, interior and exterior, right? Again, this in interior and exterior we have two categories. One we call it as co-exterior and the other one we call it as alternate exterior. Here also one set is called as co-interior and the other set is called as alternate exterior. The name itself is suggesting the pair of angles, pair of co-interior angles. Interior means it has to be inside. Co-interior means it has to be on the co in the sense same side of the transversal. So 3, 4, 5, 6 these are the interior angles, and for the transversal the angles which are on the same side 4, 5 and then 3, 6. These 4, 5 are the co-interior angles, 3, 6 are co-interior angles. 4, 5 pair of co-interior angles, 3, 6 pair of co-interior angles. In the same way for exterior also, this same side 1 and 8 exterior. So 1, 8 co-exterior angles, 2, 7 co-exterior angles. Here also 1, 8 and 2, 7 are pair of co-exterior angles, right? And in the same way, alternate interior and alternate exterior. Interior, interior, exterior, exterior. Alternate means either side of the transversal. If you look, this 4 and 6, okay, this 4 and 6 is the alternate exterior. the pair of angles 4, 6, alternate exterior. The pair of angles 3, 5, alternate interior, right? And here also 1 and 7, they are exterior and the two alternate. 2 and 8, they are exterior and the two alternate. In both the cases 1, 7, 2, 8, alternate exterior angles. So finally, if you have a transversal with two different lines, the transversal will surely make 8 angles, and those 8 angles are named in different ways. The first thing is corresponding angles, and later we observe those angles as interior and exterior, and among interior we have two categories: pair of co-interior, pair of alternate interior, and then pair of co-exterior, pair of alternate exterior. See, pair of co-interior in both the cases 4, 5 and 3, 6, pair of co-interior. Pair of co-exterior 1, 8 and 2, 7, 1, 8 and 2, 7, co-exterior. And then alternate interior 4, 6, 3, 5, alternate interior. 1, 7, 2, 8, 1, 7, 2, 8, alternate exterior. This is the categorization of the angles. These names we need to keep in mind to solve different problems. If the problem is in a diagrammatic way, then there is no usage with the names. If the problem is in theoretical way, we need to analyze the question to solve. So we need to know about the naming of all these angles, right? So this is the task. So different naming of angles which are formed with a transversal with two different lines. Now what I am going to tell you another logic. Okay. The next logic what we are going to discuss is, we named all these angles, okay, in different ways. Now another thing is, already in the previous video we discussed about the adjacent angles, linear pairs as well as vertically opposite angles. If you look in both the cases, here what you say, this 1 and 3 are what? This 1 and 3 are vertically opposite. So if the measures of these two are equal, see 1 and 3 are vertically opposite. So the measure of all these two angles are equal. So if you say this angle is alpha, this angle is also alpha. And the same way, these two are also vertically opposite, as well as this alpha and these two are linear pair. So since that is alpha, this is 180 minus alpha. So automatically this angle is also 180 minus alpha. Alpha, alpha, 180 minus alpha, 180 minus alpha. Here in this case also, alpha, alpha, and this is 180 minus alpha. This is also 180 minus alpha. And coming to here also the same logic. These two are vertically opposite. If this angle is beta, this angle is also beta. And automatically this is 180 minus beta. Why it is 180 minus beta? Because it forms a line. Since it is beta, it should be 180 minus beta. So this angle is also 180 minus beta. The same thing work out here also. If this angle is beta, this is also beta because vertically opposite. Then this is 180 minus beta because these two are linear pair, and automatically this is also 180 minus beta. See, the simple thing which we discussed in the previous video, that vertically opposite angles are equal as well as sum of the angles on a line are 180 degrees. With that, this is 4 angles, alpha, alpha, 180 minus alpha, and there another 4, beta, beta, 180 minus beta, 180 minus beta. Okay, as a count, a transversal forms 8 angles with 2 lines, but if you observe, there are only 2 different angles, alpha and beta. If you know alpha and beta, we can write all the 8 angles. If you know alpha and beta, we can write all the 8 angles in both the cases. This is the thing happens in intersecting lines case as well as in parallel lines case. But a beautiful thing which is also acceptable in the parallel lines case is the corresponding angles axiom. We say it as what? Corresponding angles axiom. See, this corresponding angles axiom suggests us that if a transversal intersects 2 parallel lines, then their corresponding angles are equal. With that suggestion, with that axiom, these corresponding angles are equal. So this beta is again equals to alpha, whereas this 180 minus beta again equals to 180 minus alpha. Then it is very clear that for a pair of lines, pair of parallel lines which is intersected by a transversal, as a count there are 8 angles, but there is only one angle alpha. If you know one angle, easily we can mention all the remaining 7 angles. This is the beautiful thing which has happened for a pair of parallel lines intersected by a transversal. Using this, we can solve many problems, and using this, we can the analyzation of this will give us more confidence to solve many problems, and in the next video I am going to deal with all those type of problems, right? So this is the video about the transversal. What is a transversal, and how many angles are formed by a transversal, and what are the different names related to those angles, and if a transversal with parallel lines, what happens? If a transversal intersects parallel lines, corresponding angles are equal. We have a corresponding angles axiom. With that axiom, this set of four angles are equal to this set of four angles. So if these four and these four are equal, then what is the useful thing from that? Then that usage and the problems related to this we are going to solve in the next video. Thank you.